On this example, we're given that cosine of t is 12 over 13 and that our angle is in the fourth quadrant. So it's important to note exactly which quadrant our angle is going to be in to help us out on positive or negative as we look at each one of these 5 trigonometric functions. So as we get going on this, I'm going to utilize the Pythagorean identity to help us out. I'm going to use the version that says sine squared of t plus cosine squared of t equals 1. Now you could easily flip-flop the cosine squared and the sine squared. I just like this version. So what I'm going to do on this is I'm going to fill in the information we're given. The 12/13 is going to go in for cosine. And when we say cosine squared of t, that means the same thing as cosine of t squared. So as I replace that in, it's going to be 12/13 is going to get squared in here. So as I square each one of those, visualizing as numerator times itself, so 12 times 12, and denominator multiplied by itself, I'm going to get to 144 over 169. And then 1 on the right-hand side. So as we want to work down and solve this, I'm going to isolate the sine squared and make this into a power equation. So I'm going to subtract the 144 over 169 to the other side. I'm going to kind of strategically rewrite this as we go. Then I'm going to write the 1 as being 169 over 169, because that's equivalent to 1, but it has that common denominator. So when I subtract away the 144 over the 169, I can just combine our numerators together and keep that common denominator. So at this point, we have sine squared of t equals, I believe we get to 25 over 169. All right, this creates a power equation, one side all raised to an exponent, constant on the other side. So to get sine by itself and get rid of the square, we're going to apply a square root to both sides. So as we do this, because we applied the square root to the problem, we want to be careful and include a positive and negative at this point. So that'll get sine of t on the left-hand side. And as we reduce this down, we can get the square root of 25 is going to be 5. The square root of 169 is going to be 13. But we want to be careful about this positive and negative. Now we are in the fourth quadrant, so that's going to really impact whether this should be positive or negative. I always tend to utilize all students take calculus. As a nice way to remember exactly what's going to be positive in each one of these quadrants. In the first quadrant, all of our trig functions are positive. Then what we do is we use the first letter of each one of these words. In the second quadrant, only sine and its reciprocal cosecant are going to be positive, tangent for the third quadrant, and cosine for the fourth quadrant. So in the fourth quadrant, cosine was positive, but sine should be negative. So it's at this point you want to include the negative out in front of what we just found here. So we got negative 5/13 for our sine value. From here, we can also go ahead and find our tangent. Tangent's going to be defined to be sine over cosine using a quotient identity. So since we know that it's sine over cosine, and we know both sine and cosine, we can kind of fill in there and say sine, our numerator, is negative 5/13. And our denominator is going to be our cosine, which is 12/13. All right, now that we have this, we have fractions inside of fractions. Let's do some reducing down. I think the easiest way to reduce this down is going to be multiply both numerator and denominator by 13. What that's going to do is it's going to create ones, right? Multiplying by 13 and dividing by 13 creates 13/13. So we'll get negative 5 in our numerator. And then as we multiply in our denominators, we get 13/13 here, creating a 1. We're going to be left with a 12 in our denominator. So negative 5/12 is our value for tangent. So after we have cosine, sine, and tangent, we can use our reciprocal identities to get these next 3. So cosecant is the reciprocal of sine. So what we can do is change our numerators and denominators. So this is going to be 13 over -5. Secant is the reciprocal of cosine, so we can invert our numerator and denominator, use its reciprocal, and say that's 13 over 12. And finally, cotangent goes hand in hand with tangent, but it's reciprocal, so 12 over -5. All right, not the only way to go about this with this given information, but I chose to use the Pythagorean identity on this one to help us solve down. Usually not too bad. Get sine, cosine, and tangent, and then get those reciprocal identities down and know which one to flip upside down to get each one of cosecant, secant, and cotangent. All right, hope this helps. Good luck.